I'm so happy to speak to you after a long time. So I hope you all are doing good and safe. Staying home is a bit bored, right? But anyway, I have sent you some notes. I would like to explain the notes, and please keep your writing book with you. Then you can go for the further clarifications easily. Right. This is national first year. So we are going to start from the note that I have sent you. So take your writing book and see, I have sent you a table. In the table there are molecules, there are ions, and I have showed you how to draw the Lewis dot dash structure, right? After that, I want to explain you more by giving examples to draw how to draw the Lewis dot dash structure. I'll take two examples. So this is my first example. I'll take carbon monoxide, right? So you know this is carbon monoxide. Before I'm going to explain this, I would like to recall your memory of, now we have learned about the Aufbau law and the Pauli exclusion theory. Because of that, actually those things will help you to understand the writing of electron configuration. Now, whenever you are in the small grades, you wrote, now let's talk about oxygen. How did you write the electronic configuration? You wrote 2 and 6. So to draw this Lewis dot dash structure, we use the outermost electrons only, right? Now here we go. Let's see how to draw this. First of all, as a beginner, we are going to identify the valence electrons, right? Now here we have carbon atom. So we'll see how many carbon atoms are there here in the valence shells. In the carbon atom, you can find how many? 4 electrons. Hydrogen, helium, lithium, beryllium, boron, carbon. So 6. Now if you are writing electronic configuration, 2 and 4. So I wrote 4. Then we'll take the valence of oxygen atom. When it comes to oxygen atom, it is 6. I'm talking about the outermost shell, right? Fine. Then let's go for a total. So what's the total here? It should be 10 electrons, right? If we have drawn the correct Lewis dot dash structure for carbon monoxide, the total value altogether there will be 10 electrons. Right, here we go. I'm starting from the first step, so easily you can do that. In the what you call the note also, I have started from the very first step. Right, I'm going to clean this. I hope you can remember the total should be 10. Anyway, I will write in the corner, the total should be 10 electrons, right? Okay, here's our first step. I'm going to draw the bonding electrons. Look at this, carbon and oxygen. How many bonding electrons at once? We have a pair, right? Then the second step, now tell me what is the more electronegative element here? What is the more electronegative atom here? That is oxygen. You can remember atoms always try to complete the octet, right? So therefore the more electronegative is oxygen, therefore it tries to complete the octet. Now here we go. Hope you can see this. Right. 2, 4, 6, 8. Octet is done. Now we have 10 electrons. We have used 8. So we have 2 more electrons remaining. So what about carbon now? Yes, the remaining should go here. Right, see whether you can understand this. Right. Now what? Okay, let's go to another step. And as more electronegative atom here, we are going to mark -1 next to oxygen atom. At the same time, we are going to write plus as a positive charge for carbon. Right? Now, see what will happen. You can choose either this pair of electrons or this. I'm going to choose this one. See what will happen. Right. Hope you can understand up to this. I'm sorry. Right. After this, what does this pair of electrons do? It will come here. So now this charge will change like this. See whether you can understand this well. Right, now we have come to the end, but they asked us to write Lewis dot dash structure. There should be a dash here. So therefore, this is your final step. So this is the final step. Right, this is your final step. These are the dashes that you want to draw. And this is the charge. Right. Now you will ask teacher, why did you write positive charge to oxygen and a minus charge to carbon? You will ask, right? Here, when we are talking about the octet rule, our priority, the fundamental theory is completion of octet. The forerunner is octet. Right? Here we are not thinking about charge. We are not giving the first place to charging criteria. So remember children, when you are drawing Lewis dot dash structure, the fundamental theory or the most important thing is completion of octet. Right? That is the thing. I hope you can understand the steps well. As a beginner, you have to start from the step by step. At home, you can practice many more molecules, right? Ions, like that I have given you examples, right? Anyway, teacher will explain the second example too, right? I hope you can understand this. I'm going to clean the board. Let's go for the second example. It is chlorine dioxide. I gave you chlorine dioxide. Let me clean this. Right, in chlorine dioxide, you have to think about the atoms. How many? Altogether we have 3 atoms. What are they? 1 atom of chlorine and 2 atoms of oxygen. Let's write, as a beginner, let's write we have to write the valence electrons of chlorine, okay, chlorine atom. Now we are going to write the valence electrons of chlorine atom. From chlorine atom we will get, yes, outermost shell, it has 7 electrons. Let's talk about oxygen. This is the example, the second example, that is chlorine dioxide, right? So oxygen atom, we have 6 electrons, but as you see there are 2 atoms, therefore I am going to multiply it by 2. So the answer is 12 electrons. The total is, you can see, I'm sorry, the total is, so what is the total here? That is 19 electron. So now you talk to your heart and see, if you have drawn the right diagram, you should have 19 electrons at the end, right? That's how it is. Anyway, I will write the number of electrons in the corner as I want the board clearly right. Okay. Now, not like the previous one, the second example, you may think how to draw this one. I am sure that you are clever enough to understand this well, because you all are clever students, I know. Right, you think chlorine is like you, oxygen, 2 atoms of oxygen are your 2 best friends. So you keep your friends this side and the other side. So that's how we are going to make the structure. I'm not going to start from the very first step, as you are clever enough to understand now, right? Let me start. Chlorine is in the middle, that is acting as a central atom, and we have oxygen. Okay, right. Now I'm going to draw the bonding electrons, right? Okay, I'm going to draw the rest of the electrons for oxygen. I hope you can remember in the previous example we drew for oxygen. At the same way you can use here too, right? Fine. How many? You need another set. Right, now let's see, 2, 4, 6, 8, 10, 12, 14, 16, then 18 and 9. Yeah, true, right? 2, 4, 6, 7. Chlorine had 17 electrons in the outermost shell. Right, done. Then as a result there are charges, right? 1, 1. So to overcome that we should write +2. Hope you can understand this well. The charge has come. Shall I write it in the like this? -1, because of that there's a +1. -1, because of that there's another +1. This results this +2. I hope you can understand that well. Anyway, I'm going to clean that. No point of writing. You all are advanced level students, so no point of giving the simpler explanations more than this. Okay, here we go. Right. Then what will happen? Like the previous example, I'm going to donate. Look what will happen as soon as it donates. Right. But here the charge is remaining. There is only one charge as that is settled. Okay. Now what about the next step? This one donates here or jumps here. So let's draw the next step. Oops, these two are a bit odd, right? Right. Now we have right now see whether you can understand up to this level. Yes. Now here we go. Now we are in the one before the last step. Dot diagram, dot structure is okay, but now we wanna go for dash. Lewis dot dash structure. Right. If you want, you can take these pair of electrons on the top and draw, no problem at all, right? That's why I am drawing it here. So let's draw the dashes. Okay. Right, now see whether you can understand this part. These two examples helps you to recognize or understand a clear view of drawing the Lewis dot dash structure. First of all, we studied or we started with writing the valence electrons in each atom. So then we took the total and we started to draw them step by step. And remember to draw that or remember to mention the charge. We are giving the priority to complete the completion of octet. That is the fundamental theory here, and not giving the priority to marking the charge, right? That is it. Okay, then I have sent you the note of, I'm cleaning the board, right? Right. Our next topic is dative covalent bond. Dative covalent bonds or bond. Let's see what is dative covalent bond. Before that, I am quite sure that you all are clever enough to recall your memory, but anyway, I will explain you from the beginning. So, what is a covalent bond? Whenever you are in the smaller classes, in the young grades, in the younger ages, you have learned to define the covalent bonds. So, when two atoms or two or more atoms sharing electrons, we call there is a covalent bond, right? And you have drawn many diagrams to prove that, and you are clever enough to recall that memory, I am sure. Today you have a new word in front of covalent bond, that is dative. Just like donation, donate. You don't feel like that, but I feel. Okay, anyway, I would like to give you a simple definition for dative covalent bond. In the exams, don't think that they will ask what is a dative covalent bond. You have to think beyond that, right? You don't by heart the theory, but you have to get the most valuable points to your head and keep it safely in your brain. But whenever time comes, you can make them to a point and present it nicely. That is the most important thing. And don't think, as I told you earlier, don't think that they will ask what is dative covalent bond. No, they'll ask beyond that, right? Therefore, I would like to give you a simple definition. I have given you the note, in the note 2, what is a dative covalent bond, right? Here we go. When atoms have empty orbitals, they interact with atoms which have lone pairs of electrons, and they are the place where dative covalent bond take place. Let me repeat once again. When atoms with empty orbitals interact with atoms with lone pairs of electrons, that is the place where dative covalent bond take place. Right? In your note, I have given you some examples, didn't I? Yes. Right. So right now when we talk about the periodic table, there are elements such as beryllium, boron. You think about their electronic configuration. When you think about their electronic configuration, they their bonds, whenever they make bonds, that is less than 4. They can't make the octet. So what do you think about those atoms? They are not stable, right? We all, now why are you learning? Why are you coming to school and learn? You are working hard. Why? You want to learn well, you want to go to the university and you want to get a degree or some other thing. You want to make a stable to go for a good job. That is the stability, right? That's what we think, but there's something else too. But for the moment, just you think, the atoms also like that. They would like to be in stable state. So, but like beryllium and boron, they have low stability. Therefore, they always seek for dative covalent bonding. If you are not good in your health, I mean if you are sick, you need the support of somebody, your mother, your father, your friend, right, your relatives. Why? Because you can't stand straight, you can't eat properly, you need the support from somebody. Like that beryllium, boron, they need the support to have the stability. That's why they always choose this dative covalent bonding. Right? I have given you some examples. Actually, we call this beryllium and boron. What? They have deficiency of electrons. You know the word, the meaning. Deficiency. The deficiency of electron. So that's why they always use for this. Anyway, I have given you some examples. I would like to go for them to discuss that. I have given 3 examples, I guess. Borine and carbon monoxide, right? Borine, you know how to write. It's this is borine. It has some other names too. Anyway, it's easy for me to call this borine. Right, and I have given you cyanide ion plus borine and carbonyl. Actually, cyanobromohydride is forming here, and the third example is ammonia plus boron trifluoride. Let me drag your attention on this. Let's go for a discussion. I'm taking this as an example. So in the third, you can see the third example. I have given ammonia and boron trifluoride. Let's see how it works. Example, I'm discussing example number 3, that is ammonia and boron trifluoride. Okay. Now, I told you boron has a scarcity of electrons or electron deficiency. So, it would like to ask lone pairs of electron from somebody else's, right? So, I hope you can now, don't go to draw the ammonia, the structure in the way that I have taught you. You know there should be angles in between the bonding, but don't go for that. We want to present how this works. So therefore, draw a normal structure for ammonia. I choose this way. You know why I kept a space here. You will learn, right? Then for boron trifluoride also I'll use this way. Right. You will understand why I have kept the space here. Right? In the example, I have pointed you out, well, it's always, right, in the example, I have pointed you how it works. See, here there is a lone pair for nitrogen that will donate to this. This is the place where dative covalent bond take place. If you don't like this, you can choose this way of drawing. I hope you can see the board. This is hydrogen. Hydrogen, oh. Here also hydrogen. Right. Now see this. This is another way of drawing. But if you are not drawing this arrow, you should remember to draw the charge. You can choose either ways, no problem at all. So, this is an example for dative covalent bonding. We have ammonia and boron trifluoride. Right? This is not a big thing. You have come across with these things, but remember how to draw the charge and how to present the dative covalent bonding. Right. Then now up to now you have talked about some of the, you have talked about, according to the example I have given you some molecules too. But now you are going to see how the metal ion forms with lone pairs, right? I have given you in the note too, just see it and go through it and see whether you cannot understand that well. Anyway, I am going to clean the board and I am going to move to the other part of the lesson, right? Now we have come to the end of our notes. See, we are going to draw a metal ion which gets a lone pair from another atom, right? In the example I have given ammonia and copper 2+ ion. You know children, we know copper has many oxidation numbers, but here we consider copper 2+ ion, right? Now, when you are in grade 13, you will come to know how to name these complex ions. Actually, now we are going to make a complex ion. How to name them, how the what you call the formation. But for the moment, we are going to learn. Actually, we want to show how the dative covalent bonding take place in iron metals. That's what we are going to do. So now let's see. Now we have ammonia and copper. We need 4 molecules of ammonia for one copper 2+ ion, right? See your note, the way I have presented it, I have kept copper 2+ ion in the middle and I need 4 molecules of ammonia. This is the presentation. This is ammonia, right? So this is a metal ion. So see what will happen. This is your final result. See, 4 molecules of ammonia with copper 2 plus ion. If you don't like this drawing, this diagram, you can choose this one. You have Cu2 plus ion here in the middle as a central atom, and you have ammonia molecule here, and the other side also you have ammonia molecule here too. This is also ammonia molecule. You better write the charge here, that is quite enough, no need to point here. So this is simple. If you mark the 2 plus here, actually no point of writing here. That is for the complete diagram, the charge is 2 plus. That's the meaning, right? Okay. So if you want to name this one, how do you name it? It is not for you now, but I would like to teach you now. Tell me, how are we going to write this? This is the complex ion that you may receive. So you can call this, can you see the board well? Shall I clean this part? See, you have to start to read this from here. Here, tetraamino copper 2 plus ion. Say it again, tetraamino copper 2 plus. Yes, that's how it is. So that's a complex ion. Don't worry, you will learn in the future. For the moment, this is to understand how the dative covalent bond take place, right? I hope you can understand this, and I will send you another new video soon. Study very well. Don't think that you are not coming to school and teachers not making troubles to you. No, not that. You have to learn well, stay at home, stay safe. I wish and I pray to see you soon. So take care and may God bless you all. Bye.